Welcome guys, we have a Holden Barina or Chevrolet Barina, Daewoo Barina, whatever you want to call it. This is a 1.6 liter Ecotec petrol engine. Doesn't have a turbo on this one. Well, symptom of the car is the cooling fan is on at all time. Okay, so also if you look in the dash here, you'll see that sign there, code, says code and a spanner sign. That's actually the engine light. The engine light actually doesn't flash, so I'll just turn the car on and you can see the engine light down here. Engine light goes away, but that code and the spanner something warning sign stays on. Another symptom with the car is whenever you turn the key on, or even when you run the car, starts the car, the cooling fan is on all the time. You can hear the cooling fan going on. It's on all the time. That's a symptom of it. Without looking too further, I already think it's got some kind of overheating, or the thermostat sensor, like a coolant temperature sensor, some kind of issue going on with this car. Okay, so let's diagnose this car. First thing, what we're gonna do, we're gonna put maybe the scan tool, and let's see what fault codes we come up with. Okay, connected to the scan tool. Let's I've already scanned the car and already pulled the fault code out. Okay, the fault code for this car is engine coolant thermostat heater control circuit and engine coolant thermostat heater control low voltage. That's where we at. That fan is, however, a little bit noisy, so I'll try to maybe go inside the car and I'll talk about it a little bit. It's saying that there's a control circuit fault. So what that means is you could have a broken wire, you could have a power or earth missing, you could have a the thermostat. This is actually an electronic thermostat on this car, so the computer can control how much it opens when it opens the thermostat, how much when it closes. Okay, so it's got an electronic thermostat, so you could have a bad coil in that thermostat. Okay, a broken coil. So we're gonna diagnose this car. Also, it says down here engine coolant thermostat heater control circuit low voltage, so that also could mean a lot of things. Okay, so it's talking about either the component, or component as in thermostat, computer, or wiring, or missing power, earth, something like this. Anything could be possible just by looking at the description of the fault codes. So what we can do here quickly, we can go to engine control module, and it's a manual transmission. Let's go to live data and we can quickly see, doesn't really matter, cruise control, we can quickly see the data here, see if you can pinpoint something out here. Not very necessary, but definitely good to just go through, just get used to the live data and all that for different cars. So I'll just start the car up. Up here you can see the coolant temperature is sitting at 39 degree. The desired electronic control, engine coolant temperature is 105 at the very top. But I think that's because we have a fault code and computer is on a default strategy, so that's why the fan is going on all the time. So just disregard that desired ECT. You can see temperature is going up slowly. It was at 39, it's 40 now. So we know the temperature sensor is working. So here it says engine coolant thermostat heater control circuit open, test status malfunction. It's showing some kind of malfunction on that thermostat, guys. Okay, Yeah, not much here we can see other than our temperature is definitely going up. It's at 44 degree Celsius. So we can go to active test now, and we can manually manually energize with the scan tool, obviously energize this thermostat. So this is very helpful when you're trying to bleed, if you don't have a special bleeding equipments, when you're doing a coolant change or changing the cooling system component, when you want to bleed the cooling system or flush the cooling system, it's always helpful, this active test. So right here, if you're going to the engine coolant thermostat heater, if you go here and if you increase this command, right, you see up here it's going 10%, 20%, 30%. You can open this thermostat all the way to 100%, and what that means is thermostat is open. Now you can bleed the system very easily, or you can flush the system very easily, not having to wait for the thermostat to open. Sometimes there will be airlock because of the thermostat. That's very helpful, just off the topic there. But what I'm really trying to see here is just trying to find a clue of things that we can do just to familiarize ourselves for the next time. Okay, it's not always necessary only this time we're gonna have this problem, we're gonna have this problem all the time. And to be honest, I have seen this in the past as well. So but for the teaching purposes, I'm just gonna go scroll through and show you guys what you can't do on the scan tool as well. Okay, so basically I can increase and decrease, obviously command the computer to open and close that thermostat. That's good. So we might use this to do our test underneath under the bonnet. So I'll just quickly turn that car off, maybe turn the ignition back on. So we're gonna go back in under the hood. That fan is noisy, it's going on all the time, so I hope you guys can hear me. Just quickly show you the components. So I'll just turn that ignition off. This fan is very noisy, so you can hear me when I'm talking. So basically down here, this is your thermostat housing. If you guys can see that. Just I get a light. So basically right here you got the top radiator hose coming in here, connects to this plastic housing, and there's some heater hose at the back as well. So that whole thing is your thermostat housing, and the thermostat actually is at the front here, just on the front section of that plastic. If you haven't seen it before, there's a couple of other hoses going in there. Now basically all I want to show you is two components here. Okay, the main components are right down here, there's a plug. So that one is our temperature sensor at the back, and if you come forward right here with the white plug, that is our thermostat control circuit. Okay, thermostat heater control, or whatever they call it in the description there. So now this is where you're going to do all our checks. We know the temperature is reading, doing something, so we know the temperature sensor is good. But when we buy this thermostat housing, you will get everything: new sensor, new thermostat, actuator, pretty much the whole housing, everything comes. So just for diagnostic purposes, we're not going to worry about the back one, we're just going to worry about this one. Now, how do I know which one is my thermostat, which one is my coolant temperature sensor? Okay, the reason I know is just looking at the plug, the size of the plug. The size of the plug on the coolant temperature right there is smaller compared to the size of the thermostat plug. Okay. Second thing, you can also notice the wires are a little bit thicker compared to the sensor wires. So because you're going to have obviously more current flow on the actuator compared to the sensor, so it's always they're always going to put a thicker wire. So this is very good tip as well, if you can remember. every time you're doing a diagnostic, if you got few components or few wires going to one component and you want to know which one's the sensors, which one's the actuators, this is always a good idea. Always thicker wires are always going to be the actuators, okay? Because the sensor doesn't have as much current flow, they're going to be very little current flow compared to actuators. Okay, now also, if you, I'll just move that out of the way. I'll just disconnect that real quick. Okay. There's a little bit of green stuff in that plug as well. This is for the actuator. That coolant is definitely leaking through that plug as well, so that's another issue we can have sometime, the coolant leak. Okay, I'm trying to zoom that in. So basically have a look in that plug and see how thick the pins are, and I'll just disconnect the sensor wire as well, and you can see the sensor. I'll just get a light. So just have a look at that sensor. Sorry guys, I'm trying to focus here. I'm using one hand. So basically look at that pins on the sensor. Very skinny pins, right, on the connector, compared to a thick pin. So that's also another way you can tell which one is the actuator and which one is the sensor. Okay, this is universally true. It works on pretty much every electrical system, any car, doesn't matter what make and model. Always look for the thick wire for the actuators. So give you an example, if you're working on an EGR valve, right? And usually these days EGR valve gonna have position sensor and also the EGR valve itself, the actuator. So usually they're gonna have 5 wires, right? Now without looking at the wiring diagram and colors of the wires, how can you tell which one's the sensors, which one's the EGR actuator? Very simple. The thick wire, the 2 thick wires, doesn't matter what color it is, it's always gonna be positive and negative for the actuator itself on the EGR valve. Now other 3 skinny wires are going to be for the position sensor, right? So what you need to see there, 5 volt, and most of the time earth, yeah, 5 volt signal and earth. That's all there is, and you don't need any wiring diagram. So basically I'm not looking at wiring diagram anything here as well. We know there's a 2 wires, 2 pin connector going in there, so we're going to have positive, negative, duty cycle, whatever the case is, we're going to see that. And on the sensor, we're not checking the sensor, but again, there's 2 wires on the sensor. If you know how this temperature sensor works, right, you're going to have a 5 volt and earth, basically. Right, so these little simple principles, if you remember these fundamentals, it helps you so much with the diagnostic in the future that you don't have to waste your time looking for wiring diagram and all that. I'm not saying wiring diagram is not necessary, but if it can obviously speed your diagnostic process and be efficient. Okay, now we're gonna check this one obviously. So what we're gonna have here is we're gonna have 2 wires, right? 2 wires connector. So we're gonna put maybe a scope or test light. You can use just the basic tools, and you can see all the signals, all the positive, negative, actuation, whatever you wanna call it, right here. If you see all that here from the computer, or fuse, wherever the power and earth comes from, we know that wiring, computer, everything up to here is good. More than likely the problem is going to be the actuator thermostat itself, right? Now there's 2 pin. You can always do a resistance test. Sometimes it could be open wire. That's already going to tell you, okay, thermostat is bad if it's open. The coil is open, right? The actuator coil. Now that's not always going to tell you the full story. Always you have to make sure the wiring is good, power supply, earth supply control is good, because you don't want to put new thermostat and realize, okay, there's another issue. I'm not getting power here, so you can get yourself in trouble like that. So always good to verify everything if possible when you're doing diagnostic like that. Okay, now I'm gonna probably show you the duty cycle. I'm pretty sure this is gonna be a duty cycle type actuator. So I would say more than likely both wires, there's two wires on this plug, right, is going to come from the computer without looking at the wiring diagram, and I don't care, I don't need it. If I am missing power or earth here, or if there's no control here, then I'll pull up a wiring diagram and start looking where these wires come from. For now, I don't care where it's come from, doesn't matter, it's computer, fuse, doesn't matter for this purpose. As long as we see control, we know everything is good. Before I hook up my scope or test light, I want to quickly do a simple resistance check on the actuator itself, right? So I'm just going to put my multimeter right here, and we'll probably go to resistance or the continuity test setting on the multimeter, right? So all I'm going to do is with my 2 test pin, I'm going to touch with the connector disconnected from the thermostat. I'm going to touch 2 pins on the actuator. Try not to cross the probes, but I'm just going to try to touch the 2 pins in there, and I got nothing. I got all open, OL on the multimeter. Okay, so what that already suggests that thermostat is bad. We already know that, but just to take the thing a little bit further and verify everything else is good, we're gonna check for control on this wire. Okay, now you can always do it plugged in, okay, but sometimes I had issue where if there's a fault code set in the computer, let's say in this case if the thermostat fault code is in the computer knows the thermostat is bad, or the thermostat circuit is bad in this case. Sometimes some cards can shut down the control to the thermostat, okay, control to that component. That means if you put a scope or something here, you might not get any signal, and you might start chasing for that issue. Why am I not getting any control or power or nothing here? Sometimes computer can shut down, so just be careful. So for that reason, if that happens, you can always trick the computer by putting a test light across that pin, right? Positive, negative on the test light. Now the computer thinks that test light is a actuator, is a thermostat, and he sees the continuity because test light has a bulb obviously and resistor, so there's going to be continuity through the bulb, through the resistor. It's going to travel back up, and computer is going to know, okay, now my thermostat is good. Okay, so let's do that. I'm going to just go and get some get a test light. So I'm just going to use this breakout lead. I'll just zoom that out a bit. I'm just going to use this breakout lead right here. It's got 6 different pins, breakouts we can use, but we're only going to use 2. So I'll just pick black and red for the testing purpose. Okay, so I'm just going to go over there and plug it into my on that plug, right? Just positive and negative, and on the other side we got positive, obviously red and black here. That's what we use. So we're gonna go to the other side here and we're gonna use that. So basically I'm just making a bridge here, guys. I'm just using a jumper. Just treat it as a jumper. You don't necessarily need all these tools, but good to have it. Makes your life very easy. Now I'm gonna connect the test light on that plug. Alright, so what I'm gonna do here is I'm just gonna put my I'm just gonna put my red lead to the red, and I'm just gonna connect my red one wire to the test light on the pin on the test light. the other side of the test light. I'm going to connect to the other. So I'm just going to use another red wire, but just don't be confused. One's a black wire, one's a red wire. Basically just 2 pin, doesn't matter which pin is what, we don't care. It's an actuator, doesn't matter which way you put the test light. If there's a power on earth, it's going to light up. Okay, so I'm just going to go. So just because we don't know if this side's going to be power or earth, just for the risk management, because we don't want to touch, if this side is the metal, is the earth, is the power side, we don't want to touch this to the metal or the bracket or around the engine. So just be careful not to touch anything. So for that reason, I'm just going to sit it on the plastic here on top of the fuse box. So now my test light is connected to that plug the way it is going to connect it to the thermostat. Okay, it's basically just another actuator. Computer thinks this is an actuator. So what I'm going to do, I'm going to go and start the car. And see, as soon as I turn this, start the car, you can see the test light is blinking. We already know that the control is good, power supply, earth, everything is good up to here, computer is good, everything is good, wiring is good, right? So at this moment, it's safe for us to go ahead and put a new thermostat and everything. There's absolutely no need to check anything else. We are good. We have no continuity on that actuator on the heater circuit. We tested with the multimeter and we got good power source control here. You can see it's blinking. Test light is blinking. If you look closely, it's not steady, that light, so it's blinking. What that means is it's a duty cycle type. So but just to show you it's a duty cycle, I'm just going to put my scope and show you that waveform quickly. I'm just on the scan tool. This one also has a scope built in. So I'm just gonna go to my scope, go measurement, oscilloscope. We'll just change that time base a little bit. We'll just go 1 second per division, and we go maybe plus minus 20 volts. That'll do. Okay, so now I got my probe hooked up. I'm just gonna go and connect this to basically I'll just back probe it. I can get the signal from this breakout lead, but I'm just gonna go behind this and back probe this plug. Okay, it doesn't matter which wire. I'm just gonna go positive and negative lead of one channel onto each wire. Okay, we could have it backwards, that's no problem, but you can see on the scope, on the screen, I'll just increase that time base a little bit. So let's go maybe 50 milliseconds. And you can see the duty cycle there. Computer is controlling in that manner. So basically the 12 volts at the top, I'll just pause that. There's a 12 volt at the top. That's the on time, and the square that drops down to 0 volt, that's the off time. I would say that's how it is. So judging by the brightness of the test light, I can say it's got about 95% duty cycle, 90% duty cycle, you can say. So basically you saw that computer is controlling, no problem whatsoever. We can see a little bit more of that. So we're happy with that result. Just pause that. I'll just go and turn the car off. So basically the conclusion is the new thermostat is gonna fix this problem. All right, guys. That's why the fan is constantly coming on. There's a service light or code something on the dashboard as well, and there's a fault code. It's all because the thermostat is bad. Now I would say the customer hasn't complained about car getting overheated or anything like that. So I would say the thermostat is stuck at an open position. Luckily, we don't want it to be we don't want it to be broken when it's on the closed position, otherwise you can have overheating issues and all that. Anyway, so we're going to change this thermostat, and that's going to fix this car. See, the whole point of this video is basically, if you know the fundamental, the basics of electricals, and it's not very hard, you just got to learn few basic things, like identifying wires, and just know what the actuators are, what the sensors are, what sort of amperage, voltage we expect on different circuits, different systems. You can do this kind of diagnostic without even looking at the wiring diagram. I didn't need a wiring diagram. I showed you everything live from the get-go. Like within 10 minutes we already diagnosed this car, and we know 100% that thermostat is gonna fix this problem. Okay, guys. Now, let's say if there was a problem when I put my oscilloscope or my test light. If the test light didn't light up while the car is running, and my scope didn't show me any control duty cycle, anything like that, that could also mean that computer is not actually actuating at this moment. Could be the temperature related. Maybe the engine is still cold. Maybe the computer hasn't decided to open or close it. However, this thermostat design works. That is possible. So for that reason, what you can do is you can always go to the scan tool, right? And while you have everything hooked up, I'll just get out of that one and I'll go back to my scope. You can always go to the active test, right? And go to coolant heater control, and you can always go here and you can command this heater to turn on or off. And I can show you that actually. Let me just go and turn the key on. I think I got the key off. All right, I got the key on. I don't need the car running. And you can see the test light is lighting up, but you can go here and you can command 10%. See, the light is blinking very, very dull. If you can see that. 10% open. I'll go increase 20%. The light's gonna go a little bit brighter. Increase 30%. Increase 40%. Light's gonna get brighter and brighter. It's a duty cycle control system. You can always command from there, and you already know that computer can control this. You got plenty of power and earth coming to that thermostat, right? Now let's say the scenario you did all that. You didn't see any light come on. You didn't see any patterns, anything on the duty cycle on the scope. What it can mean is you could have a broken wire, you could have a power supply issue, you could have a computer issue. Computer could be bad, that circuit in the computer could be bad. And if you get to that point and then you find out I need to go further, dig further into this problem, then you can go and have a look at the wiring diagram and see where all the wire go to, where the power comes from, where the ground comes from, where the computer is, which pin location is in the computer for this heater circuit, the thermostat circuit. But most of the time, diagnosis is easy. Most of the time you get problems like this, like very simple. Within 5-10 minutes you can diagnose the car and you already make your money. Just because you are good at it, right? You diagnose this car within 5 minutes doesn't mean you can charge like $10 to customer because you only spend 5 minutes diagnosing. No, it took years of practice to get to that stage where you can do things without looking at the information and wiring diagram. So no, customer will still be charged for at least, I don't know, half an hour, 1 hour diagnostic fee, whatever your hourly rate is, but you save time. So what that means is you're still getting paid $100 an hour, whatever, for the diagnostic of this one car, but you finish this job in 5 minutes. See, when you know all the fundamentals, it's pretty. 90% of the electrical problems come into your door is pretty simple. You know, it's all basic fundamentals. All right, guys, saying all that, hope you understand what I'm trying to say. If you want to follow me, I can teach you all this stuff. Like, it's very, very simple. 90% of the car diagnostics is very simple. I can show you, teach you, like, no problem at all. Saying that, have a good day, guys. I'm gonna continue and maybe change this thermostat. I'm not gonna show you the after result because I'm very confident the thermostat gonna fix this car.